Over to you, Marta.
Cool. Okay. So let's start. Well, thank you first for this introduction. And also thank you everybody for being here today. From the people who is connecting here in Spain at 6 at the afternoon. I'm aware it's a bit late. Maybe you have been working all day or studying all day. And even though you're here to keep learning things about data. So not bad. I'm going to try to do my best and to make this presentation fun and brief. And most importantly, interesting for you and that you can take the most of it. So let's begin. This is the agenda that I will follow. I'm going to start presenting myself, who I am, what have I studied, and where I'm working right now. Once we have a little bit my context and you also have an idea of my knowledge, what is my background and my history, I will present the basics of non-advertising. I'm not sure about the backgrounds that we have here. Maybe some of you have known something about non-advertising. Maybe it's the first time that you hear about this. So I'm going to try to explain it like the basics, but I'm aware that I will explain a lot of things and a lot of information. So if at any time you have any question, as Ruth was saying before, just interrupt me and I will try to explain it better or with more details so we can continue with the rest of the presentation. So once we have this understanding of what is online advertising, we will go to the interesting part, how data can help us in this field of online advertising, how we can improve all the stakeholders, the benefits, and all the things that we can do here. Later, at the end, I'm going to switch to the company where I work, which is ExoClick. I will present a little bit the department where we work, what we do, how we manage all this data in this ecosystem of the online advertising. And at the end, I'm going to present a few projects that we have been working on because I think it's interesting, once that we have learned all the theory, to put it in an example, in a real example with real problems from the beginning, all the things that happen, so we can also learn from those experiences. So now that we know more or less what we are going to see, let's start. My name is Marta Expósito. I'm from Barcelona. And a little bit about my studies. I started studying a bachelor's degree in engineering in the University Pompeu Fabra that was about audiovisual telecommunications. That basically is like telecommunications. The difference is that it has a lot of subjects that you can choose that are focused on image processing and audio processing. That's where I started working with data and these kind of things, mainly in MATLAB. But yeah, it was like the root of my career. For me, it was a very interesting experience because I had these two big escapes that has impacted a lot in my career. Basically, they are a summer school that I did in Denmark, in the Aalborg University, and an internship that I did in Technicolor. About the summer school, it was important for me because it was the first time that I have gone abroad and that I meet people from different countries, that we had to do a project in English. For me, that was a big thing. And also because we had to do all the steps from having an idea of something that we wanted to do and to create the code with several people working on it, and later to present it to somewhere like in the product stage. The project, if you are curious about, was a system that was able to recognize who was talking. So we were recording ourselves, and in MATLAB, that system, that model was able to say if it was me or if it was my colleague or who was the person talking. The experience of the internship, I think it's also something interesting to mention here, is because, well, it was my first job experience. Also, it was cool because it was outside, it was in France, and mainly because it was a Technicolor. Maybe, I don't know if you know about Technicolor, but Technicolor is a quite big company, quite important international company that is mainly focused on cinema. And it has this big office in France that is huge, and they only do things related to research. So it was very cool in the sense that I was going to work every day there, and everybody was into research, in the state of the art of everything. The discussions were super interesting, and it motivated me a lot to keep working on image processing, computer vision, but also to start cultivating this passion also about research. Once I finished this internship, I had very clear that I wanted to keep learning about that. So in this sense, I enrolled the computer vision master that is done here in Barcelona as well, in the Autónoma University. This master is interesting because, well, it's very intense. I have to say, it's only 1 year. You almost don't sleep in that year, but you learn a lot of things. I think it's a cool experience to growth in this area. The projects were very interesting. Here I show an image of my colleagues where we did this model that was able to detect the sign traffics. So for example, for cars that are driving in an autonomous way, can detect if there is a stop, and if the person is not stopping, it will stop automatically. So in this kind of functions. And it was important for me, this master, because at the end of the master, my master dissertation, I was able to do it in a lab that was focused on neuroscience, which projects that were super cool, but from a point of view from data and computer vision. So just to give you an idea, the project I was working on for my master's was trying to detect beauty in images. So that was crazy. Every time that I explain this, everybody says like, but how are you going to detect beauty in images? This is subjective. But we kind of built a model that was able to do something like that. Of course, we had to build our own database to do a crowdsourcing experiment, asking people to rate the images and see if they like it or not, and many other things in order to do that. But it was very interesting also to know how all the brain works and all these things. And at the end of this project, the results were so promising that they offered me a position to keep working there in a project, an international project that they had called Explora. And for me, that was also super important because I was able to bring all this knowledge, all this project experience, everything to different conferences, to write papers, all these kind of things. So it made me closer to the research world. And I saw that I really like it, all the academy and research field. But when I finished this Explora project, I wanted to take a break of research, and I also wanted to try what happened in the industry world. Because, you know, I didn't want in the future to regret that I spent too much time in research and these kind of things. I also want to have some industry work in order to be able to compare which one I prefer and which one it was better for me. So in this sense, I started looking for jobs, positions. I didn't know what kind of roles I could work because, you know, I've been studying computer vision, machine learning, but at the moment, I didn't know what kind of jobs there were outside. So I started doing some research, and I found out about data science and data analysts, and I didn't know what they meant. So I started doing some research. I took some courses on Coursera to know the basics and so on. And in my mind, I thought, okay, this is kind of similar to what I've been doing, because at the end, I've been working with images from databases. I was computing some features and building a model to answer some research questions. So I guess that data science could be something similar, maybe not for images, another kind of data, but to answer business questions. So let's give it a try. So after some internships, I ended up working in ExoClick, who is the company where I work actually. And it has been great because, well, many things. On one side, because it's a huge company in the sense of data, they have tons of data. To give you an idea, we are processing every day around 8 billion ad impressions every day. So imagine at the end of the year, the volumes of data that we have. For someone who likes data and that wants to study data science, this is like a dream come true because, you know, many problems that we have sometimes as data scientists or data analysts is that we want to build models, but we are not able to do it because we lack the data. So in there, it was like a paradise of data where we could explore, analyze, and build different things. This on one sense. So for my career in data science and to explore if I really like that, it was great. But also, it was a good experience because they offered me, because one day I was talking to my manager there, and I mentioned that I had this pass on research and that I like it, and they offered me to do an industrial PhD with them. So for me, that was like, wow, now I have it all. I have the industry part and I have the academic part. I can do all the things that I like. So, okay, now more or less you have an idea of who I am, what have I studied, what are my specializations and these things. Let's go into matter. I already talked about impressions, but what are impressions? Let's contextualize all this field. As I was saying before, I'm not sure if you are familiar with this online advertising world. So at the end of the presentation, we will have some time as well to do some Q&A and to answer some questions or anything that you want. But if there is something that is not clear, just interrupt me. And so we can also continue with it, right? Okay, so I'm going to start presenting a little bit the stakeholders that are involved in online advertising. The main stakeholder that we can find is the advertiser. The advertiser is the person, or also it could be a company, that is currently advertising a product, a service, or even an event with one objective, to obtain ROI. ROI, I don't know if you know what it means, but it stands for return of investment. So basically, in plain words, this means that someone wants to show to the public the product. It's going to spend money to do that with advertisement, and they have an objective, to have something in return. This something might be many things. It could be that someone goes to the website and buys a product. It could also mean like someone just subscribes to the website, so they have this user in their website. Or it could also be a follower on Instagram. There are many things. This is something that the advertiser has to define. What is ROI for him? On the other hand, we have the publisher. The publisher is the person who has a digital space that can sell to put ads on it. So as an example, a publisher could be someone with a website. So I have this website, and in the website, I will place a space that will be only for ads. And I will earn money by showing ads there. That could be a publisher, and also with the objective to obtain revenue. In the middle of the advertiser and the publisher, we have the ad tech companies. There are many kinds of ad tech companies. We are not going to go reviewing all of them because otherwise this presentation would be infinite. But just to give you an idea, all of them have the same goal, which is to obtain revenue by helping the advertiser or the publisher or even both to manage their online advertising activity. So they go and say to the advertisers, look, I found this interesting website. Maybe it's good for you. Do you want to try it? And they are helping them to improve the ROI or the revenue. And in a parallel side that sometimes is forgotten, but it's super important, we have the user. What do we mean by user here in online advertising? The user is the person who is visiting the publisher's digital space. So in example that I was saying before, a publisher that has a website. If I visit that website, I could be the user, right? And also, it could be a potential customer for the advertiser. I say potential because, for example, if a user doesn't see the ad, then it's very difficult that it's going to be a customer for the advertiser because he is not aware of the ad. But if I'm clicking on the ad and I buy something, I will be a customer. So it's interesting for the advertiser, but it's a potential customer. Okay, so now that we have all the stakeholders presented and we know who is who, let's see what they have to do to obtain the ROI and to obtain the revenue. Here I have designed this flow, this chart, that shows a little bit these interactions that they have to do. We see like that the advertiser, the thing that they have to do is to create a campaign. We will see later what it means to create a campaign, but just that you are start to be familiar with the names. So the advertiser will create a campaign and the publisher will create the ad zone. In the middle, in order to obtain the revenue and the ROI, I'm not sure if you can see the point in the cursor, but here you see it. The revenue and the here. And the ROI, we need the campaign objectives. There are many campaign objectives, but the main ones are explained here. It could be an impression, a click, or a conversion. An impression is when an ad is shown. So if I'm visiting the website and I see an ad, there would be an impression. It's the same as to say to see an ad. Another campaign objective is a click. That basically means that someone clicks on the ad. And a conversion, it could be whatever the advertiser wants. It could be the subscription. It could be someone visiting the website of the advertiser. He has to define this, and that would be the conversion for the advertiser. So a lot of information, a lot of new words. Let's put an example so we can understand it better. Always examples are the best way to understand things. So I created this cartoon myself in order to visualize all the steps and everything. So let's say that the advertiser is this girl here that has the clothes in orange, and that she wants to promote a laptop. What she needs to do is to create a campaign And this campaign, for example, she could go to an ad network, like where I work, ExoClick, and register to create an account. Okay, my name is blah, 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 and I want to create a campaign. So they create this campaign where she will upload a picture or the ad that she wants to show, and she will need to define different things. Between all the different things, she needs to define one that is very important, that is how much she wants to pay for that campaign. Also, there are many other options. For example, if she wants to show it only to people who lives in Barcelona, or that she wants to show it to people who has the latest version of one iPhone, because she's very interested in people who buys iPhones. All these kind of things will be defined in the campaign creation. Then we have the publisher who has this website, and he has decided that he's going to place this ad zone, that is the space where the ad will be displayed, in order to earn revenue. Once she has this website created, she will also go to an ad network or to another company to submit this website and say, hey, I have this website. Do you have some ads that I can place here in order to obtain revenue? And once this is done, let's say that the next day we have this user that is visiting the publisher's website. So in the moment that he is writing in the browser the URL of the website and the website is loading, this process will happen. This process is called ad serving. And it's crazy, this process, because what it does basically is it will look for all the campaigns available that match this website. When I mean match, I mean that it's going to check the country. If it's Barcelona, what campaigns wants to show the ad in Barcelona, and different parameters. And once it finds all the campaigns, it will sort them by how much they pay. And it will pick the campaign that pays the most. So basically it's an auction. It's like a real auction when you have a product and you say, hey, who wants to buy this? You offer $3, okay, and you $5. It's exactly the same, but this is done automatically and with thousands and thousands of campaigns and different zones in the same time. So let's say that in our example, our campaign here has win this ad zone. So in this case, the image of the laptop will be shown and the advertiser will pay the publisher. Okay, so far it seems logic. It seems that it's not that complicated, but indeed we can see some complications here. That we can see that it's not that straightforward as it seems. On one hand, to create this campaign, it's very difficult. Why? Because for the advertiser to know how much she needs to pay, how do you know how much you should pay for your campaign? Maybe you are paying too much. Maybe you are paying a crazy amount of dollars, and then you don't have the return of investment is very low. So you have spent money, you have wasted. Also, how do you know to who to target? Let's say the example before. I'm targeting people who live in Barcelona. But why not to target people who live in Spain or in Europe? Maybe the results could be better. How do you know that? You need data to know that. You need to do some analysis there. Also, something that I haven't mentioned on the example, but it's super important, and it's the user experience. I'm sure that you're familiar with ads that are super annoying, and maybe you want to visit a website, and suddenly you see a lot of ads coming up, you don't know how to close them, you want to browse, and you don't see the close button, and you are at the end, you are sick of the ads. And online advertising, it's very important to take care about this, because if we annoy the users, we are losing our potential customers and the visits on the websites. So we want people who are happy with ads, because otherwise the business is down. Also, this ad serving process, that is the ad serving that looks for the campaigns and the ad zones, is super complex, as you can already see, because doing all this math in milliseconds, because every time that you are loading a website, this has to happen super fast before you realize. Otherwise, it would be really weird that you are visiting the website and suddenly the ad serving process happens and now the ad has been loaded. And finally, the metrics is also something that is challenging because in this online advertising, we need to measure a lot of things. We need to measure the impressions, the clicks, the campaigns, and some of these values we cannot measure. Imagine that you're an advertiser and you want to know the clicks. For you, it's very difficult to know that. You need to rely on the information of the ad network or the publisher, or someone who has the code to measure the clicks. So, and also it could happen that, for example, impressions. Maybe what I understand for an impression, for another person, they calculate this different. Maybe they are filtering impressions that haven't had enough time to be loaded, or with errors, or any more things. So this metric part is also quite complex. So now that we have this overview of online advertising, who are the main stakeholders, we have seen that it's not that straightforward, that there are many things where we need help here. Let's see how data can offer us this help. In order to do that, I'm going to present the 5 examples that are like the most popular ones. If you start in the online advertising, you will see like there has been a lot of effort working on these examples. I'm going to present it now, just the name, so you start feeling familiar with the names. But don't worry, because later we will go into detail and we will explain better what they mean and how data can help us. So just to give you an overview about what I was saying about creating a campaign that was difficult, something that has been studied a lot is how to offer a better targeting to the advertisers and how to choose a good bid. What I mean when I talk about bid, I mean how much advertiser is paying. So, you know, if I'm paying $1, $2, those would be bids. On the sense of trying to improve also the ad serving experience, as you have seen, there are many metrics that we need to measure. So also a lot of work has been done trying to predict those metrics. One of those is the CTR. In terms of trying to have a better standardized measurements and metrics, also a lot of work has been done in data science to help detect fraud and also to help improve our systems with a technique that is called throttling optimization. So let's review them. What are those words, what they mean, and okay, but how data can help us exactly. About targeting. Targeting is, I already explained a little bit before, but let's give it like a formal definition. Targeting is what an advertiser do in order to segment their audience. So when I was saying I want people who lives in Barcelona or in Spain, I'm already targeting. I'm selecting in all my audience to who I want to target and show my ad. And in the targeting, we usually find like these 3 main categories when we want to target. They offer, usually people offer these targeting options, which are based or in demographics, which means basically the gender, the age. If you want to target to people who is, I don't know, teenager or people who is older, also the country, all these would be demographics, who tells information about the people. Also, we could target, instead of the users, the websites. And in order to do that, we would target the content. So for example, if I want to show my ad only in websites that are specialized on video games, so I would be targeting this category. And the other option would be to target behaviors. So for example, let's say that I want to promote a new video game. I might be interested on targeting to those users that have searched it in the browser. And what are the top 10 list of video games this year? So that might be a interesting targeting for me, because if I want to sell this video game, that's a sector that probably likes video games and is willing to buy a new one. So in this context, data science can help us in many ways. One of the most common is, for example, when I was mentioning here the categorization to target a specific website, how we imagine that you're on a network, that you have plenty of websites, and you need to label them. To do this manually would be very difficult. So in this sense, we could try to find clusters on our websites and do this labeling automatically. So to show an example, we have this image here. Let's say that each dot represents one of our websites. And we have created this clusterization where we can see that there are these groups here in different colors saying this websites belongs to this class. That once that we have analyzed, we realize that it's related to websites related to health, for example. This cluster here, this group, are usually websites that are about cars. So once we have these clusters, when we have a new website registered, for us, it would be very easy to say, okay, let's see to what cluster is closer, so we can assign a new label. and we don't need to have a resource of a big team doing this manually. Also, another application that data science can help us here to improve the targeting related to the content, instead of doing this clusterization, it could be to have some kind of text scraper. So to have an algorithm that visits the website and looks for specific keywords, and with these keywords to apply natural language processing, or even something more basic, just to find the keywords and see if it belongs to something that you know that from a dictionary that belongs to a specific class. So if I have a category that is games and I see Zelda, for example, I know that there is more chances to belong to this class. So these kind of things, data science can help us a lot. There are some applications here that we can find. Another example, which is super important, is the bit optimization. So in order to understand this, I'm going to show this example that I have prepared here, so you can see a little bit the problem, and then we will understand how data science can help us. Let's say that we are an advertiser, and we want to promote an ad that is a big sale, something that we want to promote, like there is a discount or something. And since we haven't promoted this ad before, we don't know how to start, we'll start with this price. So I'm going to pay $0.1 each time that my ad is shown in a website. I run my campaign, and this ad is shown in 4 different websites. Let's say that this, although they look the same, they are different, okay? After 1 day of traffic, the day ends, and I see the stats and the numbers. And what I see that the first website, it has some people visiting the website, but nobody has bought my product. So I don't have any money back. The second website, it happened the same. I am with $0. For the third, oh, look, I have 0.2. So I have spent 0.1 and I'm having more money. So it was a good website. Oops, I think that it has crashed. Give me a second.
No problem.
They didn't like the second website.
I didn't like that website. There we go.
Cool. So as I was saying, the last website, in this case, someone bought some products, but I spent 0.1, but I have recovered 0.1. So I'm not earning extra money here. So at the end, after 1 day of my campaign, I have spent 0.4 for the 4 websites, but the results are negative. I'm losing money with this example. So after 1 day of traffic, if I am the advertiser here, there are some lessons that I can learn, right? I could say, okay, for next time, I will discard these websites. I will block them in a blacklist, for example. And maybe for this website, since I know that I am not earning much money, maybe I should pay less. Let's try to pay less and see if I can have the same money. And like that, I will not be losing money. This is great. And this is something that advertisers needs to do. But in real life, this is almost impossible. Why? Because we have usually many impressions. And to review all the websites, you would need all day to do that and to know exactly how to optimize the bid. Also, okay, here I can pay a little bit less, but how much less? Because I don't know if maybe I'm paying less, I will not win the auction and my impression will not be displayed here. So in this sense, we can create an algorithm that based on the information from the past, we can see, for example, if I create a new campaign and I had a campaign very similar in the past, we can learn the experiences from that campaign and apply it directly to this campaign. So like that, we are already, for example, we could have a probability that say us for each website, what would be our return. Like that, we could block it already and just invest on those websites that we know that there are more chances that we will have some money back. Also, this algorithm could tell us how to adjust this bid price, so we don't have to do it manually. For example, by doing during 1 hour, it's trying the algorithm how it's going on. If the results are positive, maybe we can keep the same price, but if they are negative, we can start decreasing a small percentage and to keep checking that, but in a way that is automatic and we don't have to spend human resources time to do that manually. Another project that is also like one of the oldest problems and that has been studied a lot, and that probably one of the ones that you might find more papers in Google Scholar is the CTR prediction. CTR stands for click-through ratio. And basically it means how much your ad has been clicked. Here I'm showing the formula. I want to show the pointer. This is the formula. That basically is a ratio between the clicks that we have obtained and the impressions that we have shown, and multiply it by 100 because it's a percentage. It's a percentage. So this way is interesting. Click-through ratio is used a lot because it's like an indicator that kind of tell us the quality of the ad. Okay, this is not always the case, but it's like something that in the industry has been established. Like in order to see the quality, we can take a look at the CTR. So the theory says that if someone is clicking on your ad, it's because they are interested on it. So that's why it's something about quality, because if people is not clicking, they are ignoring and your ad is not interesting at all. But what I'm saying is not true 100%, because maybe someone has clicked your ad by accident and they don't want to buy anything. They don't like maybe it's because they don't know how to close it and they click it on it like that by an accident. But still it's interesting, and that's why people keep looking at it in order to see how the things are going. And why it's interesting here in our case, in data science. So let's say that we are like, for example, that we are Google, we are a search engine. And you know that when you are searching something on Google, at the first searches, usually they are ads. And then you have all the results. You can see there like, this is an ad or a sponsor, or I don't remember the exact word that they use, but you can see that it's an ad. And how Google can decide what ad should go first? Because usually the ads that appear first usually receive more clicks because it's the first thing that the user sees. So it's important, that decision, which one you will put first. We might think that, okay, it's the ad serving process, right? They just look for all the ads and rank for the one that is bidding the highest, and the one who pays more will win the spot. Yes and no. Let's see an example. Let's say that we have these two ads. One is paying $1 and the other one is paying $2. But because the CTR, we know that the first one has a 10% probability of being clicked, and the other one has 1% probability of being clicked. So in this case, according to the probability, we might think that after showing the ad 100 times, the first ad will return us $10, but the second ad will return us just $2. So in this scenario, it would be better to show the first ad, right? This is great, and this is why CTR is used to also rank this and to help the ad serving to make this decision better. But what happens? Sometimes we can't calculate the CTRs. Let's say that we have a new ad, a new campaign that we have never tested before, and we cannot calculate this formula because we don't know the clicks, we don't know the impressions, or maybe we don't have enough data to do it. It's then when the CTR prediction comes here. We can use data science to build models that predict this based on different things, also based on past campaigns, to know what is the ad about. Maybe this ad was shown in a different country, so we can see how it was in that country and we can estimate it in this new location. And that's why there is so much interest in CTR prediction. Also, there are many other predictions. It has done for the conversions. There are algorithms that calculate the conversion prediction and many other things. There is this project, another one, and I'm finished. Don't worry. I know there is a lot of projects here and information, and maybe you are already a little bit overwhelmed, but I promise this one is super interesting. I think that you will like it because we are talking about cybercrimes. So what is fraud in online advertising? We can find two kinds of blocks, two kinds of different fraud types. There is the publisher fraud and the advertiser fraud, which is usually called violations because they are kind of more severe. When we talk about publisher fraud, it's because in this online advertising ecosystem, sometimes people are not very honest and they try to cheat people in order to earn an extra amount of money. How they do that? Here there are some examples, but believe me, there are many more. They are very creative. One of the most typical ones is the clip bots. So they build these machines, and that basically what they do is that in an automatic way, and the machine click on the ad. So if an advertiser is paying for a click, the advertiser will be paying for clicks that has been done by a bot. But of course, the advertiser doesn't want that. He wants clicks that are from humans because they are the potential customer. A bot will not buy the product. Another kind of fraud would be the ghost ads. These are publishers who is telling you, yeah, look, this website, I have shown 100 impressions, but it's not true. Then you visit the website and there are no ads whatsoever. It's completely empty. So it's also lying about impressions. And also there are the fake sites. This could mean two different things. It could be like, for example, a publisher has created a website and they have created an account in a company to submit this website to receive traffic there. And once it has been approved, then they change the content and show something else, and maybe it's very violent or it's not right. And of course, it has passed all the controls from the ad network or the company, but then they change the content and nobody realized that until a user visits the website and surprise. So how, in this context, data science can help us? We need to detect that. In an ideal world, what would be perfect is to have people visiting all the websites during all the day to see if there's something weird, like windows that are being opened without nobody clicking on it, things like that. But that's impossible because imagine an network that has thousands of websites. We cannot have people visiting during all the day, all the websites every time. It would be impossible to do that. And even though maybe you are not detecting it, because maybe the fraud happens only when you are connecting from Germany. And if I'm visiting the website from Spain, I don't see this pattern. So data science here can help us to build models that detect this kind of strange behaviors. So if we can model what is normal from all our data, because we assume that from all our data, we will have more normal than weird things, right? So if we can model what is normal, for us it's very easy to detect these outliers. And maybe those outliers are not fraud. Maybe something happened there. Maybe it's a technical issue. I mean, we cannot rely 100% on the machine. But with these systems, we can create like flags or alarms that then humans can review and say, look, yes, this is fraud, or maybe no, it was a mistake from the machine. It's all right. But at least I'm only reviewing 100 websites instead of 1 million. From the point of view of the advertiser, this is even worse. Because sometimes advertisers, they don't want just to earn an extra revenue, they want to harm the user. This is an example of people who are creating ads, and when you click on the ad, they show you a ransomware. Ransomware is, well, here this image showing an example, is when you see this message saying, look, I have all your private data, all your pictures, and if you don't pay me, I will show it to everybody, all your friends, your colleagues at work. They try to threat you, so you pay them money, and usually this amount is quite high. Some things that also goes in this line are the browser lockers. That would be this example here. So when you click on the ad, you go to this website, for example, and then you cannot close the browser. It's blocked. And it's showing this message here that if the only way to fix this issue is that you call a specific number, or else that you pay an amount or something like that. Something a little bit less bad, if we can say like that, could be the scare words, but still they are bad. These are ads, or it could be ads that you click on the ad and you go to another place that from the advertiser that is telling you things that are not true. In the sense like, look, your computer, it looks like your computer has been infected by a malware. Try to install this antivirus to solve it. And it's not true. Your computer hasn't been infected, and probably that antivirus is not an antivirus at all. And similar, there is the malware, which basically you click on the ad and there is a file that has been downloaded in your computer. Maybe you don't know it, that has been downloaded, and it's installing weird things there in the background without your permission. So here, it's a little bit more difficult in the sense to detect that in the other case, where we could build models and so on, but still there are some things that we can do. For example, we can try to visit periodically, maybe not every day, but each time, those URLs from the advertisers and analyzing, for example, the content. If we can find, for example, attack, ransomware, this kind of words, we can also raise an alarm in our systems to see, look, this advertiser has an advert that is not very normal. Let's review them. Or also, we could review the URLs and to check, for example, in VirusTotal or this kind of websites to see if they have been blacklisted already and see a little bit if someone has detected that they are bad or not. Something that can be also done, but it's a little bit more difficult, but it's also a solution, is to analyze a little bit the behavior of the advertiser. So for example, an advertiser who is new and he's starting a campaign with a very big amount of dollars, let's say I'm a new advertiser, I have this new campaign and I will pay $100 each time that there is an impression. That's weird because usually advertisers start low because they don't know how it will behave. It's the big problem that I was saying before. You don't know, so it's better to start low. So I'm starting in the big, with very big numbers. That's weird. Why? Usually advertisers that do that, it's not like 100% of the times, but it would be an indicator that they want to reach to the maximum amount of users in very short time to spread this malware or these bad things before they are caught, because they know that they will be caught. But if they are detected in one day, maybe during that day, they have been able to already show the ad 1,000 times to 1,000 different persons. So they have already spread the fear and everything. So that's also something interesting to take into account. And the last project, I'm very brief here. This I wanted to show you because I think it's very interesting, not only for advertising, but in general for data scientists and data analysts. And it's because sometimes we are so focused on building models that are very cool, that can solve problems that have 99% of accuracy predicting something, but we don't think on the infrastructure. And later, when we want to apply this model, the people who work in IT or in the system sites tell us, very nice, but this is quite heavy. It requires a lot of resources, a lot of GPU, and we cannot do it. So what do you do with your model? In this sense, I'm going to focus, this goes into this line, but let's go inside on advertising, how we can see that here. Let's say that we have this ad server process that is all the time doing all this math with all the campaigns and advertisers, and who is constantly listening to all the requests that we are receiving. So for example, right now, I have a request that a publisher has a website and there is a spot to show an ad. To have a system that is constantly listening to all these requests all the time is very costly, especially depending on the amounts that we are talking. Let's say, for example, ExoClick, who is serving 8 billion impressions per day. So 8 billion impressions that has to be processed by a system. Of course, we need to take into account this infrastructure cost, because maybe what we are earning, maybe these impressions are returning me an amount of money, and this amount of money is lower than the infrastructure cost. So at the end, I'm losing money here. So that's something to take into account. How we can solve this? So for example, we can analyze what clients, what requests, for example, we are never winning. So let's say that we have a publisher that all the time is saying, look, I have here a spot. Do you want to show an ad? And all our advertisers who are bidding, they always lose. So then why should I listen to this publisher? Maybe instead of listening 100% all the time, that publisher, I can start listening half of the times. And if I see that I start winning again, I will increase this throttle. And if not, I will decrease it. Like that, I am limiting the cost and just keeping those requests that are the best ones, that are the most profitable for me. This is also interesting because, well, right now there is a lot of controversy that all this infrastructure cost is not about money, also for the environment. So we need to think about the environment as well. Cool. So we have presented, we have seen some use cases of data science in advertising, how data science can help us and data analysis. But this is very nice and very beautiful, but we have some challenges here that are not that nice. and that we need to take into account when we are creating these models and working on these projects. One of them is the time that our models and predictions will take to give us a result or a prediction. Because when we are dealing with so many dimensions, take into account that in online advertising, we have many dimensions. We have the country, the browser, the device, different things that we need to manage. And all these models need to process all this data. For this reason, to build anything in real time, it's very difficult. It's almost impossible. We need to think very thoughtful how to build something that is going to be applied in real time. What is usually done is to build models that are built overnight. And once we have this overnight with all the model created and everything, then to have these predictions during the day. But to have something real time, we need to design this model very, very well done. On another hand, and it's also related, is how we are going to compute these experiments, how we are going to train these models, to use these models, because the infrastructures to host all these data experiments are expensive. So are we going to have our own systems, our own computers, servers to do all these experiments, or should we go to the cloud? We need to take into account also how much it's going to cost us, because machine learning and data science is super cool. We can see a lot of things that can be done, but we need always to take into mind, okay, what is the return? How much, what is the value? Because there is a lot of cost, the cost of the machines, the cloud. So this is something that needs to be in the equation, and sometimes we forgot. And finally, this one that is very sad, but it's true, is that in online advertising, what I found with my experience is that to measure the impact of any change is super difficult. Why is that? Because the market is changing all the time. So maybe right now there is a new client, maybe something happened in a specific country, and maybe you apply a new feature, something new, and you see a positive change, like, look, we are earning more revenue. But maybe it's not because you changed, maybe it's because something happened outside. So you need to filter all this noise, and this is super complicated to do. And yeah, I think I summarized all the challenges here. So now that we have seen all this, let's see what happens in real life. So I'm going to talk about ExoClick, the ad network where I work, which I'm super happy about it, and I'm going to explain how cool we are there. I'm going to start talking about the department where I work. So I work in the business intelligence department. What is business intelligence? I'm sure that you already know this, but let's see like the formal definition, because like data science, there are many definitions out there, and we can pick the one that we prefer because it seems that there is no consensus. So I found this one here that I like it, that basically defines business intelligence as the technological framework that enables corporations to explore, analyze, and model large amounts of complex data with one goal, to improve business performance. So in 4 words, okay, because these were a lot of words, let's summarize it. Business intelligence tries to enable data-driven decisions. So don't take me wrong. Decisions that are taken based on experience and intuition, they are also good and they are also important. People who has worked in a business during a lot of years and that know the business very well, they know how to do things. They know why things happen. And maybe with data, we cannot see what is the best solution to one problem. Maybe someone with experience can help us better. But if we can combine both things, the experience with the data, then we have this super powerful model to improve much more our decisions. Because of course, sometimes even our experience, our knowledge cannot help us to know what audience is the best, what happened in a specific day, and all these things. We need data. So how we can do that? How we can provide these data-driven decisions to the people who work in advertising and in any other field? This is the classical cycle decision that basically, as you might be familiar, it consists on first place, to be able to get the data. This is not always straightforward because, as you might know, data comes in different formats, in different sources, and might be one of the most complicated steps. But once we have the data, it would be the part of studying the data to see what we have. From data analysis, we would be able to detect problems, to detect issues, or to think about new features. Once we have that, we need to think the action plan. Okay, what we are going to do with that. We want to change something in the company. how we are going to do this change, who is involved. And later, this is also super difficult to do, to enact the change. Because let's see an example. Let's say in a department that all her life has worked with spreadsheets. And now you want to implement a new dashboard in Tableau or any other tool. To do this transition might be very difficult because maybe all the company is used to these spreadsheets and maybe they don't want to change. They don't see the value. So we need to show the value, to do some courses to explain how this tool works and to push so this change happen. It's not only, okay, here's the model and now it's your problem. No, we have worked on something and as a data scientist, as a data analyst, we like to see that this thing that we have done is used later. Otherwise, we are wasting our time. And once this change has been done, we start again. Maybe we need to evaluate how the change was. It was a positive change, no? And like this until the infinite. So in ExoClick, we do this and many more things. So basically, I put here like the main tasks that we had. We had many more, but just to give you an idea, since we work in an online advertising field, we are between people who work with clients and people who is very connected with technology. And we need to be the bridge that connects both sides, people who work in the sales with technology. Because sometimes these two worlds are, the communication is not that straightforward. We need to understand what clients want so we can translate that later to our technological team. On the other hand, we also need to provide ad hoc analysis and also, let's say that we want to create a new feature, a new model that predicts CTR, for example. In order to create this and that will later be applied, we need to create a model and see the value, to estimate the value, so we can also provide, demonstrate that it's worthy, that we should invest in creating this in our platform. Also, we need to study what infrastructures are needed when we want to create a new model. Or if we want to implement something new for other departments, what tools they will need to do all this study. Moreover, we also do this kind of role of product management. We have our own product managers in the team, but we can help them to do this analysis so we see the value of each product. And finally, and very important as well, is to be all the time searching and looking what other people is doing. In my case, that I'm doing the PhD, I'm all the times looking at research and state-of-the-art papers. But as well, we need to check what are doing the competence, what are doing other networks and these kind of things, because maybe they are doing something interesting that we might also want to do or to improve, and so on. So this is cool, but then it comes the real life, and it's not that straightforward and that nice. As I said at the beginning of the presentation, we in ExoClick have a lot of data, and this data comes from different kinds of sources and formats. We have data that comes from our traffic, like the campaigns and how much they are paying, our clients, the dates, all these kind of things. Also, we have data that comes from our platform, from the clients, when they log in our platform, when they create a new campaign or something like that. We have data from our systems, like if we have errors or what are the CPU, the memory, to see if there is something that we should take into account that we will not have a technical issue later or something like that. And all this data need to be processed and studied. But this visualization of the data is complex and we need tools that help us to do that. In the business department of ExoClick, we work with Jupyter notebooks, we use Python, and in this environment, we have built our own internal libraries that can connect to the different data source the databases, and we can combine all these different sources in an efficient way and with all the with different functionalities like to convert the data times so they are all in the same in UTC or the format that we need it, and these kind of things. This is for business intelligence purposes to do our own analysis. But for the clients, we also have this API where they can connect and retrieve the data that they need so they don't have to log in the platform and check it from there. They can have their own spreadsheets and do the things that they need, their dashboards and everything. We also create dashboards that are run periodically to different departments of the company because It's a way that to optimize their work. If they have to go every day and open the platform and extract the data and create the same dashboards, they will spend a lot of time. So if we can create these dashboards already and to show them, they arrive at the office, they have the dashboards, and they can then start working without having to do all this work before. And also different reports that might not be dashboards, it could be different tables and so on. But that's also some way that we provide to visualize this kind of data. Cool. Now let's see some of the projects that we have done and what happened. This is one of the projects that I really like to talk about. I really enjoyed this project because it was about computer vision. And it was a project about automatic creative categorization. This project was born because some time ago, I don't remember, I think 2 years ago, Google announced that all the ads that had one of these elements here will be blocked because they were bad for the user. These elements were, for example, an imitating close or cancel button or a download button. I'm sure that you're familiar with this. Before we had Netflix and we had all these platforms, when we wanted to see a movie, some of we could go to a platform and download one of those files. But then we had like many download buttons and we didn't know which one to choose because we didn't know which one was the true button. No, this is the image here showing this. And you didn't know if you click on this button, maybe you will see an ad, maybe your computer will crash. So it was kind of scary. So Google wanted to stop this to happen, no? And they say that all the ads that were showing this kind of elements, they will be penalized and they will stop working. So if I click on it, nothing will happen. So this is an example of a button, but there are many other elements like a play button that maybe you click on the ad because you think that it's a video, but then nothing reproduces and these kind of things. In order to detect that, of course, we have a lot of ads on our platform. And we had to do this fast because we had some time to remove them. But of course, it was quite a heavy task. We had people reviewing them manually, but it was very time consuming. And also we wanted to do this more efficiently. So for example, if someone creates a new ad, that this could already be detected by a machine. So for this reason, we trained a model with deep learning that gives us a probability of having one of these elements. So for example, here, that this would be an ad that is tricking the user that maybe you would click on it, but it's not a video. And in here, our algorithm would return an array with these values. So what is the probability of having a close button, a download or play button, a blinky element. Blinky element is an element that is flashing all the time and it's like annoying. And this was like that. It looks very easy, but it was super complicated to do because on first place, we had to build our own database. So we had to do all this labeling by hand ourselves. And also because these play buttons usually are like transparent and they have many different things on the background. This example here looks very nice, but it's one example between 1 million. The other ones had things in the background and it was very difficult for the machine to detect this without taking into account the background that is in between, the transparency layer. Also, something that happened to us that I think is quite funny is this problem that maybe you are familiar with. Is that sometimes deep learning, as you might know, is specialized on finding some low-level features like the colors, the shapes, the textures. And therefore, images that have these elements very similar, the algorithm might be confused and think that it's the same thing. So for example, here we have an example of this cute dog and some nuggets. And in this case, the machine thought that they were the same thing, that all of them were dogs. And it makes sense. I mean, if you close a little bit your eyes like that, you might also think that they are the same thing if you don't see all the details, right? And here is another example as well, that the colors are very similar. And this same thing happened to us. We found that we had a lot of images that were labeled as play button. But when we look at the images, they were shoes. Because if you look at it, it has a similar shape, like a triangle shape, and also the color are like dark. So in this sense, and usually play buttons have this cycle that I was saying before, but the algorithm wasn't not detecting like a pattern there because it was changing. So at the end, this is the thing that he was looking at. So in order to fix that, we had to look for a lot of images with different shoes. So we could teach the machine that, look, this is not a play button, this is a shoe, please stop labeling this like that. Another project that was quite interesting was this one to detect scareware. I already explained what was scareware before. It's this message that is saying, look, your computer is infected, download this antivirus, or in this case, call this phone number here. And that is bad for the user because it's tricking them. He has no infection on the computer or whatsoever. So we already had a system in place to detect that. But this system was not working all the time pretty well. Some cases it was working fine, but there were some that we were skipping and we had a lot of false positives. So for example, we detected that websites that were about cybersecurity, so people who wanted to learn about cybersecurity, visit that website, and we were detecting words like malware, and we thought it was a page about malware, but it was about preventing malware or learning about malware, not about malware itself, right? So in this sense, we saw that to have this kind of dictionary that was detecting the words, and if there is malware, it's a malware. This was not working fine. We need something more intelligent. So for this reason, we switched the system with something that was taking into account the context with an algorithm based on natural language processing. So it's not just that have malware, but it has to have a combination of words and that the context tell us that it's maybe not that it's malware, but to tell us a probability. That's also something important because sometimes things are not like white and black. For this kind of models, usually it's better to have a probability, and depending on that probability, to take an action or not, to review them or just to discard it or whatever you see that's better. So that's the last project that I wanted to show here. I'm going to show this screen now here because you have here also my contact details in case you want to add me or later if you want to send me any message or whatever. But I think that we have, I don't know what time is it. I think we have some time. If you have any questions, we can also discuss anything that you find interesting. Now it's your turn.
Thank you very much.